Oh, welcome
Hello,
to
Jodie.
SmartarseTube. Hello, Jez. SmartarseTube. See, there you go. He's being a smart arse already, straight away.
Yeah.
Okay, so I'm wearing glasses. So I'm going to attempt to look intellectual because he's the intellectual here. I'm just...
Okay.
Okay, okay.
What are we doing? We are trying to explain everything.
We are trying to
That's
explain
quite a
everything.
tall order, isn't it?
It's a very tall order.
But
he's a very tall man.
Just as well.
6'6", I tell you.
No, I'm not.
6'6", he stood on the ground.
6'5".
Why?
Yeah, you can't exaggerate anything or else it becomes...
Oh no, you can't exaggerate anything. Yes. Okay.
Yeah, so here we go. What are we doing with this thing? We are trying to explain all the things that people are interested in. Well, not everybody's interested in, but some people are interested in. People have asked the questions that people have asked for centuries, and that, judging by the plethora of videos on YouTube, that they're still interested in asking, but are nowhere near answering.
Indeed.
So, being smart asses,
yes.
the conceit is that we have all the answers.
Do we have all the answers?
Well, the answers that matter. Answers that matter. There's always more questions and answers that come out of it all, but that's detail.
Yeah.
And not really relevant to establishing the foundations of everything. So, the idea of SmartarseTube is that we will explore all those questions, give answers that work, and what's more, eventually, some evidence that those answers are the correct answers.
Yes.
That'd be good, wouldn't it?
That would be good. Wouldn't that make a change? Wouldn't it make a change?
It would be not only closer to the truth, but it would be the
truth.
Yes.
There we go.
We hope, that's what we hope for.
Well, yeah, let's get a bit closer because, let's see me on that camera
in the picture,
too. It's alright because you can't see me because it's too bright.
Yeah. Okay.
But it's
Anyway,
so far away, what is the nature of the question that we are asking tonight?
In the last video we did, or the first video we did, we talked a bit about the nature of reality existence.
Yeah.
Existence rather than reality, because existence encompasses a lot more than just reality.
Right.
Reality being the universe. Existence encompasses life, the universe, and everything.
Yes.
To quote Douglas Adams.
Yes. The perception of life and existence.
So there's a whole bunch of other things, depending on your outlook, that either exist or don't exist. Often called Platonic ideals.
That's an interesting thing.
So Plato's ideas of the world. Plato had the idea that there was a whole existence of ideals. Now, whether it's all been translated properly over the centuries is neither here nor there. Nowadays people say, oh no, can't be doing with that, that's dualistic thinking. If not magical thinking.
And what is dualistic thinking, Jazz?
Well, dualistic thinking is, it's the idea, it all comes back to Descartes really. Well, no, it goes back to Plato, but Descartes was the kind of like turning point, maybe you could call it, when he said that there was res cogitans, or cogitans,
I would go with cogitans.
I don't know how the Italians, the Romans said it.
Roman, isn't it?
But yeah, Latin.
Which is ironic because he was in fact Greek rather than Roman.
He was French.
French. Well, yeah.
Descartes was French.
Yeah, but Plato's
Greek.
Greek. That's what
yeah.
I was saying.
Yeah, well, there you go. It's all Greek to me. Yeah, so where were we? Res cogitans and res extensa. The extended world and the thinking world.
Yes.
Or the place, or the things of thinking, things of extension. Things of extension, easy. The real world.
Yeah.
Stuff that is real, exists, you can do science on, and all of that, and the material. Now, a lot of people are materialists, and they say there is only the material world, only the material, very serious, only the material world, and they deny the existence of anything else beyond the material. Of course, that's slightly confused thinking, because it assumes things like that the past exists, and this is the view that Einstein, I believe, subscribed to.
Right.
That there was some kind of block universe, that all the past was just as real as the present. Now, if that was true, if that was true, it raises all sorts of problems. Like, well, where does all the new stuff come from?
Yes.
How does it grow?
Yes.
But then there's the idea that this block universe extends into the future, and it all just is, and we're just somehow progressing through it.
And the past
There's
is
a big
there,
question
and all
there about
how
our experience of now progresses from yesterday through today to tomorrow.
Yes.
If indeed it does, which Mr. McTaggart had a few things to say about that.
Okay, and who's Mr. McTaggart, Jazz?
JME, so I think he was John McTaggart, Ellis McTaggart, which sounds like a funny name, but there's a very good reason why he had that name. He had that name because he was christened John McTaggart Ellis. Because that was his parents' name, Ellis, but named McTaggart after a rich relative, as often was done in the old days, in the hope that the rich relative would leave them all the dosh, which indeed the rich relative did.
So but that was a bit of precognition, if you ask me.
On the condition that the Ellises changed their name to McTaggart.
Hey,
so
what's in a name?
Well, yeah, exactly. So John McTaggart Ellis became John McTaggart Ellis McTaggart, which is great.
It is because it is the satisfactory outcome from both parent or grandparents.
Everybody's happy.
Everybody's happy.
Except poor old
so if you have a situation,
except poor old McTaggart the elder, who's dead.
But he's lived a happy life and made lots of money in that time.
Something like that.
Okay.
Anyway,
enough of him.
He had lots. John JME McTaggart had a lot to say about time, and but anyway, we don't really need to go into that.
No.
You can look it up on Wikipedia if you like.
There you go. Right, so continue.
So, let's bring it back to dualism. The whole concept of the material only being the material is, I think, flawed, because, well, for a start, some things are true.
Indeed.
And they are true even when they've gone into the past. Now, of course, with Einstein's block universe, the past is still there. So
Indeed.
that carries on being a truth maker, as philosophers would call it. But it's still a bit of an assumption that the past is still there in all its material glory. And there's no evidence that it is.
Indeed.
Has
anybody gone back to the 18th century and come back and said...
Well, exactly. No time travel. Within the confines of relativity, there's the idea that because I guess it's because it's an idea, it doesn't make a lot of sense to me, but if you're moving a certain speed, different things will appear to be in your presence, and if you're moving very quickly, you'll appear, if you calculate it, the way physicists do, it appears as if the plane of what could be considered your presence changes its angle compared to everybody else's presence. So a theoretical idea is that all times are equally real.
Okay.
Now, I think this is misunderstanding the nature of reality, and that in fact when you go from the starting point that we were discussing before,
right,
where everything starts from numbers, and then the numbers, from that emerges the physics, and from the physics emerges the chemistry, and so on and so on in life, and eventually comes out of that, you end up with an idea that actually time itself is an emergent quality or property of things, or
right,
as is space.
Yeah.
And we'll get onto that in more detail maybe. But from that, it's very, very clear, to me anyway, that there is only now.
This is something I've always thought. There's only now. You can only live in the present.
There's objections to that, of course. People object to it, generally scientists object to it on the grounds that you have to have a universal reference frame, which basically means you have to have a starting point from which to measure all these nows. They all. But what I'll do is describe a very simple universe, and hopefully that will explain where they're all going wrong. But I'm not going to do that just yet, because that's getting ahead of ourselves.
Right.
And we're still stuck on dualism.
Yes.
But enough to say, suffice to say, for now, that there is this idea that there is only the material universe. The dualist side of it says, well, there's the material, but there's also all the ideas, and that they have a separate existence that is not actually linked to any particular place, is not actually linked to the material at all. And this was the problem for Princess Elizabeth, not Queen Elizabeth, but Princess Elizabeth of Bavaria, I believe, or Bavaria or Bohemia or somewhere like that, somewhere Germanic,
European,
who was a correspondent of Descartes, and who objected when he explained, when he let her know his ideas, or she found out about them. She said, well, it's all very well, this res cogitans and extensor, but how on earth do they interact? Well, she had a good point, really. And this is the objection to dualism, is if these things are different, how do they interact?
That is a good
So
question.
that is something we'll have to answer. But we will answer it in due course. And the answer will come down to a thing called downward causation.
Ooh, now.
So downward causation is the opposite, really, of emergence. So emergence is a fundamental concept to my understanding of existence.
Yes.
And as we were talking about Sperry's wheel, very good example of emergence.
Yes, indeed.
The going round and round
Yeah.
is an emergent thing that comes out of the material properties of the or parts of the wheel, but only occurs because of the whole of the wheel. Now this is fundamental. I mean, okay, that's just a material example. And as with all these things, people argue about them in different ways to try and pick holes, which is good. It's good that they try and pick holes in the arguments because
they're trying to clarify the situation.
they try and be sure of what the answer is.
Yeah.
But the thing is, or what that brings us back to is, because we're talking about numbers and how the numbers are virtual. Right, so the numbers, it's only as if they existed.
Yes.
And that they would and do, I believe, push each other into existence by the very paradox of one being 0 and 1 and that being two things and so on and so on, and 2 makes 3 and it's all dividing up. You've still got the whole of existence, even when it's just a few numbers, being a whole thing that is, and every whole thing is a whole thing. Every whole thing is a one.
That's right.
That is what it means to be one, to be solitary is to be one, but is also to be unified with every other whole thing. Because wholeness is a common property. Which brings us back to Leibniz's law and the identity of indiscernibilities, or indiscernibles.
Right.
So we then get on to, well, what do these things make? These numbers, they're not like the numbers you write, those are numerals, that's different.
Okay.
But these numbers, they are just virtual relationships between things.
We have the spirits in the house tonight. Never mind.
There we go.
That's great.
Wedged in there.
That's even
So,
better.
Right, okay. So where were we? We were on the
Indiscernibles.
what are these virtual things? Well, everything, not only is everything a single thing, everything is a whole thing, single, whole, one, unitary, whatever you want to call it. The whole universe shares the same wholeness as the whole of me, or the whole of the table, or the whole of the camera, or the whatever. So, but whole things are composed of parts, and that is there's a relationship between all the parts and all the wholes.
I'm going to ask you a really silly question here.
Yeah.
Okay, got a glass of water.
Yeah.
It was a whole glass of water.
It's still a whole glass of water.
Is that a whole glass of water?
It doesn't
because
matter
it's
how
a
much
glass.
it changes. It's a whole glass.
Yeah.
And it's a whole glass of water.
Right. So I asked the question about the contents now.
The contents don't matter. They are the parts. The glass is the parts. One part is glass. One part is water. The water is made up of atoms or molecules of H2O. It's also parts.
Very good.
Everything overlaps.
It clarifies the situation.
Anyway, so coming back to what is virtual, virtual just means that there is a relationship that exists. It exists. It doesn't have to be real. It doesn't have to be material. It just has to be a relationship between two things that are. You can only have a. Well, every relationship is a connection, and it says that there is a relationship is between two things. It can then extend to other things, but the bare bones of a relationship is it's two, what we'd call in the computer world, two nodes.
Right, yeah.
So it's either end, sometimes called the subject and the object.
Yes.
And then there's the nature of the relationship between them.
Right.
So either subject and object, they are to some extent the same, and to some extent different.
Right.
If they're identical,
then they're going to be the same.
they are indiscernible.
Yeah.
They are the same.
Yes.
And it's just one thing.
Yes.
If it's indiscernible, it's not. There is no difference between this one and that one, and so they're the same one. This is what Leibniz came up with.
Yes.
And but to the extent that they are different, they are apart. Now, so every different thing is in some way stands in some relationship to every other different thing.
Yeah.
The thing about that relationship is it just is. Just by virtue, or the virtualness, the virtue is, it just means like the property of the thing.
Yeah.
Yeah, so like 1 and 2 are in relationship to each other because they're both the same, they're both numbers, they're both whole things, so they're both the same in that respect. But 2 is both the whole thing divided, so 2 is both half of a whole of 1, and it is twice as much as 1. There's twice as many parts to it as there is for 1. 1 only has one part of 1. It is just 1. It is literally 0 and nothing and 1. It's nothing and something. That makes 1. 2 is that divided into 2 parts, and therefore 2 has 2 whole things in it, and so it's different by its two-ness, the amount of its two-ness from the oneness of 1.
Yes.
So it's the same and different. So it's this kind of paradoxical thing, but everything's like that. Every number's like that, but also every other thing is like that. So every object, and it can be a virtual object, in kind of everything is a virtual object, but for every object there's a certain relationship. That chest of drawers is a certain different, it's not chest of drawers, a sideboard, but it's a certain distance from me. It is in relation that way. The camera is in relation that way.
Yes.
There's a difference.
Yeah.
Now, the differences are a relationship. They're a relationship that makes space. The space wouldn't be there if the things weren't there to define the differences. Now, this departs wildly from the modern way of looking at the universe, which is to say, it's all fields. The field is the thing, and all the objects are just disturbances in the field. Well, that may be a very convenient calculatory
exercise.
Tool, but I think it's a fiction, and I think that what actually happens is that the numbers emerge, and from the numbers emerge particles, and from particles emerge positions, and because some of these particles are quite complex, i.e. they have more than just a couple of dimensions, or more than one dimension, they are, as soon as you have what we consider a particle with mass, it has a relationship to other particles
Right.
that maybe also have mass.
Right.
That means that for all these relationships, they cannot fit into what you might describe as a flat space. Now, when I say flat, I just mean three-dimensional. A three-dimensional box, because as soon as you put some masses into that box, those masses, their mathematical properties distort everything in the box. So you have basically a drawing together because of all the numerical values of these things, and the only way that they can respond to that paradox of being a certain distance but also having these other properties which change the differences between them, i.e. give them mass, is for them to actually be pushed into what we call the imaginary dimension. Right, so this effectively, mathematically, is a rotation.
Okay.
So a rotation of an object into the imaginary dimension, the more it rotates, the more effect its mass has.
Right.
I.e. it becomes more massive. So mass is just those numbers, that little cluster of numbers being rotated into the imaginary dimension.
Right.
And the more energy, we call it energy as well, but mass and energy are equivalent. There's rest mass is, if you had the thing on its own with nothing else around, it would be able to sit there unrotated. It would have its own internal energy, which gave it mass internally. But because of it has this relationship to the other things in the box, it gets rotated around just through the paradox of not being able to maintain that same distance and be energetic at the same time. Now these are just words to try and describe something that's just a collection of numbers, really. So when we say mass or energy, we're talking about the same thing, but essentially you're saying here's a little cluster of numbers rotated a certain amount, and because it can only rotate 90 degrees, that means there's a limit on how far you can, because if essentially rotating, giving a mass more energy, is accelerating it. Why does it accelerate it? Because it makes it respond more to the effects of changes everywhere. And so there's a limit to the amount you can accelerate it to, which is the whole rotation into the imaginary. If you're completely rotated into the imaginary, that's like a 90-degree rotation mathematically, and there is no more you can go, and that is why there is a speed limit on things. The speed of light is because it's a 90-degree rotation.
Yes.
And this is what happens with light.
Right.
So light has no mass as such, or a sort of theoretical mass, but there is no mass to it. Light doesn't even exist. The photon is not a thing that exists. It's only as if it exists. What is a photon? A photon is a subtraction.
Right.
Yeah. It's not a subtraction of a number. It's a subtraction, I think, of a square number.
Okay.
Because we get the square root of I gets involved rather than I itself.
Right.
I rather is the square root of -1.
Okay. Yes.
So that imaginary rotation
Mhm.
is employing the square root of a negative,
Okay.
i.e. it is the subtraction of a square.
Okay.
So you've got to imagine two electrons, so charged particles, and we'll call them
The ABCD
Alice and
theory.
Bob. Alice
Yes.
and Bob, right?
Yeah.
Because traditionally in science they call them A and B.
Yes.
Alice and Bob.
Yes.
They're not trying to be sexist about it or
No.
gender specific
No,
or
I
anything like
get
that.
that.
It's,
I get that.
so Alice and Bob, they're both charged particles.
Right.
They both have mass, so we call them electrons for the sake of argument.
Why not?
They both have mass, so they're both slightly rotated into the imaginary
Mhm.
through the mass.
Mhm.
That's energy.
Mm.
The energy is effectively a store of stuff that they can use to make photons.
Okay.
When Alice gives up a photon,
Mm.
one photon, so
One
say we'll
photon.
talk it a bit in terms of ones
Keep it
because
ones.
it keeps it simple.
Yeah.
Right? So one is subtracted from Alice.
Mm.
It can only be subtracted from Alice by being added to Bob,
Mhm.
because in this particular universe there's only Alice and Bob.
Mhm.
So Alice can only give up her one by giving it to Bob.
Right.
So you have a subtraction of one
Mhm.
and an addition of one.
Yes.
So that subtraction of one
Mhm.
is a subtraction of an imaginary quality.
Right.
Yeah.
Yeah.
So Alice unrotates a little bit.
Mm.
She becomes a little bit less,
Mm.
energetic,
Mm.
a little bit less massive.
Mm.
It's like she's gone on a diet or something. I don't know.
Yeah, it's like somebody coming to wheel grace and
So-
changing their diet.
She goes a step away, less imaginary.
Yes.
I mean, the imaginary dimension. It's not that she's imaginary; it's the dimension.
Yes.
Is
Yes.
the rotation. It's all imaginary,
Yeah.
really. But anyway,
Mm.
that's beside the point. She rotates one little bit one way.
Mhm.
Bob has a plus one,
Mhm.
so he just goes, and he becomes more massive.
Mm.
He's added to.
But he doesn't rotate.
So you have a subtraction and an addition.
Mm.
That we don't have to worry at all about. There's no times involved here.
Mm. Mm.
It's just as it happens.
Yeah.
You know,
Well-
for Alice to lose a bit,
Mhm.
Bob has to gain a bit
Yes.
at the same time,
Yes.
at the same moment,
Yeah.
at the same instant.
Yeah.
And
So what's the
That's-
effect of distance on
that's
the,
well, it
on-
doesn't
on
matter. The
these?
distance is nothing. That's just the difference between
Mm.
Alice and Bob. It could be a little bit. It could be a
Mm.
lot. It doesn't makes no difference.
Mm.
It's just that Bob says. Well, he doesn't say anything, but it's as if he said, "Yeah, I'll have that." But in having it, in taking it on board,
Mm.
he rotates a bit. He becomes more massive, more energetic.
Mm.
Rotates a bit more into the imaginary.
Mhm.
So effectively, if we were looking at it as how into the imaginary they are,
Mm.
Alice comes down a bit, Bob goes up a bit.
Mm.
So boom,
Mm.
they both move,
Mm.
and there's no time involved. Photons experience no time. Well, they don't exist. It's as if there was a photon.
Mm.
There's a certain quantity of energy that's gone in a certain amount of distance,
Mhm.
and that amount of energy, because it goes at the full rotation, because the subtraction is a subtraction of the whole root of minus one,
Mm.
it's a unit as it were, it goes at the speed of light.
Mm.
It's all all or nothing with photons, because it's a post hoc situation.
Right.
After the thing,
After
hoc
the
the
thing.
thing, post after.
Mm.
So post hoc, looking at it, if
Mhm.
anyone was looking at it, they would say, that was a certain amount of energy at a certain speed of light.
Mhm.
It must have had a certain wavelength,
Mm. Mm.
and so the wavelength and the frequency,
Mhm.
which are just factors of the speed of light,
Right.
and the amount of energy that's transferred is it's only as if it was there after the events. It's not really, the photon wasn't there, nothing moved across, nothing was in between ever. It was just left Alice, got to Bob.
Oh. Right.
That's instant.
That's instant, yeah.
So how does this help us with things like time and gravity and things like that?
Logical question.
What's the simplest universe, really? I mean, we could imagine just Alice and Bob, but it doesn't get us very far. Let's imagine that we've also got a third object there, a third electron. We call him Charlie. Call it Charlie. Alice, Bob and Charlie. That is the universe. Now, if Alice and Bob are a certain distance, there's a certain difference between them that we translate as distance, but it's just difference. There's a midpoint.
Right, yeah.
There's got to be a midpoint between Alice and Bob, i.e. the difference, whatever the difference is, there's a half of the difference. If you've got Charlie as well, and this is ultra simplifying things beyond what's real, but it's just for illustration, as they say in the insurance world. Charlie is also going to be a certain distance from Bob, and a certain, or difference from Bob, and a certain difference from Alice. But Charlie is unaffected by Alice giving something to Bob. Charlie doesn't even know about it. I mean, he's just there. And these three things, but there is a midpoint between Alice, Bob and Charlie that is somewhere between all three of them. Now, it may be that it's very difficult to calculate that. It may be that the precise numbers don't yet exist to calculate it fully. Okay. But triangulating between these three differences, you would get ever smaller, closer approximations to a point that where it is depends entirely on the differences between Charlie, Bob and Alice. And this point is a virtual point. Right. And because Charlie, Bob and Alice are all slightly imaginary, because they all have mass, as one moves, or in fact as two move, because they have to move two at a time, that point that's in the middle will also move. Right. Okay. Yeah. That point in the middle is the centre of this little universe. In fact, we can call this universe a thing, because it's the whole of Alice, Bob and Charlie. Yeah. It's a thing, so let's give it a name. Let's call it Dave. We'll call it Dave because Dave's not there.
There you go.
I love that
Dave
joke.
is not there.
Dave's not there.
That. Yeah.
Cheech and Chong, if anyone.
There are references.
Dave's not here.
There are references to this, and it's very comedic, I can say. So,
anyway, that's a whole another story. But so Dave is the whole. Right. The whole has a heart. Dave's got a heart.
Centre of being. Yeah.
The centre of Dave, the point in the middle, is defined by the parts of Dave. Right. Yes. And that's true of everything that exists.
Indeed.
Is that it has its parts, it has the centre of its parts. It's why the Earth's got a centre of gravity. It's why the Earth goes around the Sun's got a centre of gravity. The moon and everything else, they all go round and round. You look in the centre, you find the exact centre, there'll probably be nothing there because, well, there's gaps between everything. but it's as if it was there. So Dave, although Dave is not there, Dave is the whole. That it's as if Dave was there. Dave has emerged from Alice, Bob, and Charlie. So there's Alice, Bob, and Charlie. When Alice gives Bob the photon, Alice goes down, Bob goes up. They're in different relative positions, so the centre moves a little bit. Now, if you've got three things and the centre moves this way a little bit, because these two bits have changed, then that is exactly the same as the centre stayed where it was, and all three of those bits changed, moved, they all moved. So you can say that when Alice gives something to Bob, the whole universe moves.
Right.
It's only a universe of three.
Yes.
But Charlie has to move as well.
Yes.
Because Charlie is moved relative to Dave. And so this is just a very simple explanation of why whenever anything changes anywhere in the universe, our universe, or any universe, the whole universe changes. Just a tiny bit, you know. It might be
infinitesimal.
Yeah, tiny bit. And of course there's changes in our universe, there's changes going on all the time everywhere. You know, zillions of them. And so when they change relative to, they're still just there, they're still just sat there. They change relative to the thing. It's then as if some change had taken place. It's as if some time had passed.
Right.
Yeah. So if you imagine a photon bouncing around between Alice, Bob, and Charlie. You know, Bob gives one to Charlie, Charlie gives it to Alice, and goes around. They're constantly changing. Each new rearrangement, each new now, is just a rearrangement of those pieces. They don't go anywhere. They don't. The differences between them change, but they move relative to the Dave.
Right.
Or Dave's heart.
Yes, Dave's heart.
The
Dave's
heart of
heart.
Dave.
Yes.
And what's happening there? Well, you could say that there's a truth to where they've been relative to each other, and you could say that if you imagined them to be sitting on the surface of a ball, at the centre of which is Dave, each new position, they're still on the surface of Dave. They're still relative to the heart of Dave, but there's all these truths going between where they were and where the heart of Dave is. So the heart of Dave, you've got a more complicated universe with more particles in it. The heart of Dave is somewhere, is not going to be on the surface.
No.
It's going to be somewhere else. But the surface is the three-dimensional space that holds Alice, Bob, and Charlie, and probably who else? Well, you could have Eric and Freddie and Gordon and whoever. I don't know. Whatever. I run short of names really after a while. Can't give them all names.
No.
And anyway, they're all pretty much the same.
Very similar.
well, it's been argued they're all identical, but that's another
Now
another
that
matter.
can't be possible.
Whole different question.
Yeah.
Thanks to Mr. Wheeler.
Mm.
Right. So where are we? We have the surface of this thing,
Mm-hmm.
and they're just on the surface.
Right.
And they because they appear to move, and they have to move. It's like almost as if the ball has lots and lots and lots of layers.
Mm. Mm.
Each one a little tick.
Mm.
The ball actually doesn't have to change. It just become, because it's only the differences between the things.
Mm-hmm. It's the differences.
But it's as if there's more divisions between Dave at the heart of it all and where Alice, Bob and Charlie currently are in the now.
Mm.
So they're only ever in the now.
Mm. Yeah.
But from Alice, Bob and Charlie's point of view, when Bob receives a photon from Alice, he thinks, oh, there's Alice over there. He's getting some inputs that if he was more complex, he would, and so on, and well, yeah, we won't say how, but
no.
effectively, if he had a mind to think about it, he'd think, oh, there's somebody over there, but he would see Alice where she was,
Yes.
not where she is in the now. So his view of Alice would be on a layer one back from the
before
surface.
we received this, before we received the
they're all only ever on the surface,
Yeah.
but when they get the change, it's where Alice used to be.
Yes. Yeah.
Or it's as
He
if
perceives it.
as
He
if
perceives
so
it from where it was.
his perception is as
right,
if
yeah.
Alice was in the past.
Yes. Yeah.
And we're all like that. We can only ever perceive things a little bit into the past. So that's separate. That's part of being separate from, materially separate from other things. And also, so this is where time comes from. The perception of time is just change. Changes. Time emerges as the perception of change. Time isn't a real thing; it's just a consequence of changes. Mainly photons bouncing around between things. I say mainly. I mean, maybe there's other particles, but you can take into account if you want to be more precise about it. But for the sake of argument, we're just considering photons. And because Alice, Bob and Charlie are all slightly imaginary, their direct lines from Dave are slightly curved. So this brings us on to relativity, and the reason space appears to be curved by mass is...
And on that, I'm going to call it to a halt for a bit, so you can get a bit of refreshment, I can get a bit of refreshment, and then we'll get restacked.
Okay.
And ready to react.
So this is the explanation of why the time and gravity emerge from quantum changes, because the photon is a quantum change, and that is the basis of reality, is quantum changes between what are really just virtual particles. Everything's just virtual. It's
did I jump in there rather?
well, I don't mind.
Okay,
Doesn't matter.
we will come back
We
on
can
that.
stop and hopefully start at a sensible point again.
Okay.